much for joining us this morning. We are so pleased to be here with you. We're going to give it just a minute for a few more people to join us, and then we're going to get started here introducing our esteemed guest, Dr. Walter Baethgen, who is the director of regional and sectoral research at IRI, which is based at the Earth Institute in Colombia, at Columbia University in New York. I'm going to quickly introduce Dr. Baethgen. I'm going to talk about housekeeping, Q&A at the end for a second, and then we are just going to get rolling. We're so pleased to have all of you with us here this morning. My name is Hannah Neuschwander. I am the Director of Communications for World Coffee Research. This is the second in a kind of new webinar series that we're calling WCR Presents, where we bring in outside experts to talk to us about scientific topics that are relevant for coffee agriculture and coffee R&D. And today we're super happy to have with us Dr. Walter Baethgen. He has focused his entire research career on multidisciplinary research and development programs that address agriculture, and especially in the last number of years on climate risk in agriculture. And he's done everything from working on the IPCC's second and third assessment reports. These are the big global reports about climate risk in the world that really helped tune the world into what was going on with climate change. He's consulted for the UN, the FAO, the World Bank, IICA, as well as many governments and the private sector in several countries. Latin America has been his focus. He is the recipient of the Morosoli de Oro Award, which recognizes his contributions to Uruguayan culture. Although he is based in New York, he is Uruguayan. So Dr. Baethgen, we are so pleased to have you here with us to talk today about a new way to think about climate change. Before I turn it over to you, I just want to quickly acknowledge the support of Duncan, which has made this web series possible, and their continued support through the Checkoff program that contributes to all of the portfolio of work that World Coffee Research does. So thank you to Duncan, and over to you, Dr. Baethgen.
All right, thank you, Hannah. Good morning, good afternoon, good evening, depending on where you are. It's great to be here, great to talk about this with you guys. The title, as it shows in the slide, is New Way to Think About Climate Change. The reason why I put it into brackets is because some of you may be already thinking about climate change in the way that I will describe. But in my experience, most people are approaching the challenge of climate change in agricultural production very often in ways that is not very effective, I would say. Now, before we get into that, and just to be sure that we are all on the same page, let's use 2 minutes to talk about what is climate change, what is causing the changes in climate. And to talk about that, we have to describe the greenhouse effect. So this is a greenhouse effect in a greenhouse. You have solar radiation getting into the greenhouse. Some of the light is reflected in the glass, but some goes into the greenhouse. And then it is re-emitted out of the soil as heat, as infrared emissions. Now, part of those infrared goes out, they go out of the greenhouse, but part again are reflected in by the glass in the roof of the greenhouse. And so the temperature inside of the greenhouse is higher than the temperature outside of the greenhouse. This is the greenhouse effect in a greenhouse. In the planet, in Earth, it's a very similar situation. You have the sun emitting radiation. Part of that radiation is absorbed by the soil and re-emitted as heat, and some escapes out from the atmosphere, but some is reflected down back into the earth. And the reason that the equivalent to the roof of the greenhouse is a group of gases that are called greenhouse gases. Now, this is a natural greenhouse effect. And the most important greenhouse gases are carbon dioxide and water vapor. And if it wasn't for this natural greenhouse effect, today the temperature will be 10 or 15 degrees colder than it is. So this is this is a greenhouse effect that allows life in the earth. What has been happening in the last centuries is that the human activities have been resulting in huge emissions of greenhouse gases, including CO2, but other greenhouse gases like methane and N2O. And what is happening now is that the roof of the atmosphere, the roof of the greenhouse, the glass is thicker. So now we have more heat being trapped inside of the planet. That is the enhanced greenhouse effect. This is what causes the global warming, and this is what affects the climate around the world. Now, because of this explanation of how climate change is being caused, of course, the main efforts should be oriented to try to reduce the causes of this effect. And that, in the climate change language, reducing the net emissions of greenhouse gases, is called mitigation. And that means reduce emissions, have more clean industrial processes, be more efficient with transportation, use more renewable energy, reduce deforestation. So that's the key. If we want to combat climate change, that's where we have to work a lot in that. Now, the problem, the challenge is that because of the inertia of the current and the past emissions in the last several decades and centuries, the effects of climate, even if the world stopped today, even if all the factories stopped, all the cars stopped, even if the world stopped emitting greenhouse gases today, because of this inertia, we will have a change in climate for decades. So we need to adapt. We need to learn how to adapt to a climate that we know we will continue to change. We hope that we will be able to reduce emissions, that we will be effective in reducing emissions. But even in that case, we know that the climate will continue to change for a while. Now, when you start interacting with users, any type of stakeholders, farmers, ministers, any user, any stakeholder, the first question when we say we need to improve adaptation to climate change, the first question they ask is, what do we need to adapt to? What will the future climate look like? And for that, to answer that question, the best tool that the science has is the climate models, global circulation models, global climate models, GCMs. And what the climate models do is they take the planet, they divide into small cells, and then in each of those cells, they go several layers up in the atmosphere and several layers down into the oceans. And then they simulate exchanges of heat, of energy between all these cells, and they simulate the circulation around the whole planet. So these are very similar to the models that I use for the weather forecast that we see every day. It's going to rain tomorrow, how hot it's going to be today. The difference is that the climate scientists have modified these models so that they can change the chemical composition of the atmospheric component in the model. So they say they can change, for example, the amount of greenhouse gases in the atmosphere. Now, we're talking about science. These models are wonderful. They have been advancing every year. It's a better version of every model, but it's science, and science, it's a progressive. It's progress, right? You learn more year by year. You learn more how to improve these models every year, and so there's still a lot of things that we need to learn. And I'm going to show you an example from the area where I come from, in Southeast South America. And the question we asked is, if you take the best climate models, how did those climate models how did they simulate the past observed climate? For example, rainfall in September, October, November, December, January, and February. So how did the model see Southern Hemisphere summer rainfall in the last 100 years in Southeast South America? This is how the best 50 models of the available in the scientific community saw rainfall from 1900 to about today. And basically you see is a pink band that shows the range of how the model saw what happened in the past with the rain in the summertime. And the line is a mean. So basically all the models agree that the rainfall in the summertime increased by around 2 to 5 millimeters per month. This is how the models saw what happened. This is how they saw history. What did actually happen? This is what happened. The black line happened. This is how much rainfall increased in that area of the world. None of the models was even close to represent those changes. Now, does this mean that the models are completely useless? No. It means that the model, like anything in science, models are improving. And there are some places in the world where they work a lot better than in this case, but there are still places in the world where there are things that we need to improve our understanding. So that's one limitation of using models to try to imagine the future climate. But I think that another, probably in my opinion, even more difficult challenge is that in order to use these models, remember I told you that you have to tell the models what is the chemical composition in the atmosphere. In other words, how much greenhouse gases will be in the atmosphere in the next several decades, which means that we need to make assumptions of what technologies will be used, how much renewable energy sources, what will be the deforestation rates, how many people will be living in the planet. Very difficult for the years 2080 to 2100. It is very, very difficult to guess how the world will evolve in all these areas. So what did the socioeconomic scientists did is they created scenarios, socioeconomic scenarios, directly related to emissions of greenhouse gases. So some scenarios are very optimistic, and they say throughout the 21st century, the emissions will be very low. And some are very pessimistic, and they say this is going to be business as usual or even worse, and the emissions will be very high. And now, with these different scenarios, with this range of scenarios of emissions, now they can connect to the climate models and predict what will happen with climate. What will happen with rainfall, what will happen with temperature. And that is where you get the typical IPCC scenario. Like Hannah was saying, IPCC is an intergovernmental panel on climate change, and is a structure that congregates all the scientific community working in climate science, right? And every 5 years, more or less, they have assessment reports. So this is the best scenarios that you can get in the world of what to expect in the future. In this case, I would use temperature, again in Southeast South America, but look at this map here. It's a huge window that includes a big part of Brazil, Bolivia, Paraguay, a big part of Argentina, all of Uruguay. So it's a huge window. Now, what are the models connected to these different socioeconomic scenarios, being more optimistic or pessimistic, saying that will happen with the temperature in the coming 80 or 100 years? This is what they're saying. So in gray is the observed temperature in that big window until today, in the last 100 years. And then in yellow is the projections of temperature for the next 100 years, if you are very optimistic. And in red, you have the projections of the temperature in the next 100 years for that big window, if we are very negative, very pessimistic. And basically what it's saying is that the temperature will be, by the end of the century, the temperature will be between, I don't know, half a degree hotter than today or 7.5 hotter than today. Which in terms, if you use this, if you were interested in, let's say, the price of oil, this is equivalent to say, by the end of the century, the price of 1 barrel of oil will be anywhere between $50 and $2,500. So it's a huge range. Saying the temperature in that big window will be between half a degree and 7.5 degrees is equivalent to that, to using a huge range. It's very difficult to do anything with a projection with that amount of uncertainty. And this is for a huge region. Normally, decision makers are not interested in huge regions. They're interested in a county. They're interested in a region within a country. If you did this exercise for that resolution, if you were interested, say, in one province of Argentina, then these ranges will be much more uncertain. So now, this is temperature. For most crops, the main driver is rainfall. If you look at the same exercise but with rainfall, this is what you get. Here you don't even get a trend. You don't even see if the rainfall will go up or down in the next 100 years. And if you look at individual models, some models will say rainfall will go up, some models will say rainfall will go down. What you can see is that the more pessimistic scenarios, they have wider bars. It looks like the year-to-year variability will increase. So again, this is for a huge window. At a local scale, which is what most of the time we are interested, the uncertainty is a lot worse. So this is a state of the art of the best tools that we have to imagine climate in the next 100 years. The conclusion is that the climate change scenarios with the best tools that we have available today are uncertain. And in fact, the objective of the scientific community that developed these scenarios was not to develop them for impact assessment, to see how that will affect corn production or malaria infection. The main objective was to generate awareness, is to make the people in the world aware that if we don't change our practices, we will be in trouble. We will be affecting the climate in a very dangerous way. It was not to do this impact assessment, but still, what is happening today, and I'm sure this is happening in coffee too, you see published articles in peer-reviewed journals, some very prestigious journals, where they show you the expected corn yields in the year 2090 at the county level, or changes in soybean yields from today by the end of the century, again by county. Now, when you see this, where is the uncertainty? What is happening here is that we have very uncertain climate models feeding some kind of crop model and then predicting the crops. So this is scientifically wrong. Now that you understand that, behind this climate change scenario we have a huge uncertainty, presenting results like this is scientifically wrong. But it's even worse than that. This type of information is very easily understandable by a decision maker, say a Minister of Agriculture or a policy maker in general. And a lot easier than telling them, well, this is a range and this is the uncertainty and we are not sure what's on. No, they understand this now. And this is a big risk then of making decisions, elaborating plans with the wrong information. To be honest, in my experience, what happens with this type of information is that it's not used at all. Because a Minister of Agriculture that receives information based on the 2080 and very quickly they learn that information is uncertain, that's the best recipe for paralysis. You provide information that is very far in the future, and you provide information that is very uncertain. So there's nothing we can do. And that's what happened. Nothing happened. Now, therefore, we need a different approach. And this is the new of the title, the new way to look at climate change adaptation. First of all, in looking at this new approach, we need to consider that climate variability, climate changes, varies at different temporal scales. And I'll give you an example from the Sahel. This is the annual rainfall in the Sahel in West Africa from 1900s until today. And one question you may want to ask yourself is, in this area, was there climate change? Is there any trend at the century scale that shows a change in rainfall? And yes, you can use statistics and you will see that from the beginning of the century until today, the total annual rainfall in that area has changed about 180 millimeters in the last 100 years. The other thing that you notice is that there are some decades where rainfall tends to be up here, and some decades where rainfall tends to be down here. So there is a decadal variability. And how big is that decadal variability? Well, that decadal variability shows that it's already bigger than this one, than the climate change. You see decades where the rainfall, total annual rainfall changed by 250 millimeters. And then you have the year-to-year variability. 1 year you have floods, and then 2 years later, before you had droughts. The year-to-year variability, where you have even bigger changes in the rainfall, annual rainfall from year to year. So the important thing of this is that depending in the area of the world, but everywhere, there is variation of climate at different time scales, year to year, decadal, and long-term of climate change. The question is, if we do this in the whole world, if we look at these all different temporal scales, the trend of climate change, the decadal and the interannual, how important is each scale? Which of those variations at different time scales explain more of the story of what happened with rainfall in the past? So what I will show you now, one example is, the annual rainfall in the last 100 years. And I will show you a set of maps showing how important those three scales were for explaining, for telling the story of what happened with rainfall in the world. If you see maps with colors that are green, that means that scale, that temporal scale, didn't explain much. If you see colors that are yellow or orange, that scale is explaining a little bit more of the story. As you see colors in the purple, that means that time scale is explaining a lot of the story of what happened. So what happened? How much of the observed changes in rainfall in the world, annual rainfall, can be explained by the climate change in the last 100 years? Mostly green colors. 5 to 10% of the story can be told based on climate change. How much? Decadal variability, 10-30%. In some places more, in the Sahel there's a little bit more, in some places less. How much of the total story of what happened with the annual rainfall can be explained by the year to year? A lot, most. And what happened with the models is that they don't see this year-to-year variability. What they mainly see is a trend. So by thinking of climate change based on these slow trends, we miss most of the story, which is the interannual variability. And then there is another example of how models can be misleading. You have East Africa. In East Africa, by 2100, most of the models agree in that the rainfall will go up, right? So this is the Great Horn of Africa. Green means more rainfall. Brown means less rainfall. 90 or more percent of the models agree that by the end of the 21st century, this is what was going to happen. What has been happening in the last 15 to 20 years? Exactly the opposite. So if we had taken measures, elaborated policy, made decisions based on this only, we would have been in trouble in the last 15 years. Now, does this mean that the projections are wrong? Maybe no. Maybe what is happening is that there is a big decadal variability, and the blue line, that is what the climate models are showing, is going up, but in the year to year and in the decades, they're going up and down, up and down. And so planning based only on these climate change scenarios is very risky. So we need a different approach. In that approach, we need to be conscious that the climate change is not a problem of the future. It's a problem of the present. It's already happening. It's not something that we need to worry about in the future. It's already happening. It's affecting climate all over the world. Now, some of the most damaging impacts of climate change, and here the scientific community completely agrees, is that it's going to, or it's being seen, and it's going to be seen even more in the future, as increased frequency of damaging events. So increased frequency of droughts, of storms, heat waves, frost. Now, those extreme events are the same events that we are confronting today, right? We have what are our worst climate threats? The droughts, the storms, heat waves, the frost. So if we improve our adaptive capacity to climate today, if we can improve our adaptation to today's climate variability, we will be able to design production systems that are more resilient and better adapted to the future climate, whatever that future climate looks like. So, but the advantage is, instead of having to wait and see if the climate projections are all right in 20 or 30 years, no, the actions is needed today. We need to concentrate on what can we do today to improve adaptation to climate today, because our systems will be more resilient, but also we will be better prepared to adapt to future climate. And yes, there's some user demands for longer term, like if you're building water reservoirs or building roads, but near term climate change, we don't need 100 years in the future. We need estimations of how this variability will change in the next 10 to 30 years. So don't need to go to the 2100. Now, when we say improve adaptation to today's climate, you guys involved in coffee production know what are the strategies to build resilience, to improve adaptation to climate today. It means diversify as much as possible. It means include irrigation where it's feasible. It means using the best genetic, the best varieties, the most resilient varieties. It means reducing uncertainty by improving the knowledge of climate of the past, learning from the past. For example, what was the best practices in past droughts? Also, by having the best possible monitoring system, what is happening today? Turn a green light if everything is fine, but turn a yellow light if you see a drought starting to show. And future, but future, what can you say for the next 2-3 months? What can you say for the next week to 1 month? How can we work with the risks associated with that? How can we forecast months ahead? For example, based on El Nino. And then, even if you do everything well, even if you use the right technologies, even if you improve all your information and reduce uncertainties, you're still going to get hit by droughts and by storms. So there's part of the climate-related risks that you're not going to be able to manage. You have to transfer that. Transfer the risk that you cannot manage. And how you transfer risk? With financial tools like insurance. And insurance that has to be accessible. And we can talk more in the questions if you want, but there are some modalities of insurance that is accessible. And related to that, I think there is a key factor here, very, very, very important for development, which is climate management and financial tools. If you think of any climate related outcome, this can be, I don't know, coffee production or crop yield. What happens is that some years they are disasters, they're catastrophes, they're very, very bad. Some years they're great, the yields are wonderful, the prices are great, and then most of the years the results are around in the middle, right? So you can think of this whole range of climate related risk into sectors. You have the crisis, the real catastrophes like Hurricane Mitch, you have droughts, right? And what happens, especially in the vulnerable farmers, what happens with vulnerable farmers is that they design their production systems mainly trying to avoid losses connected to these years. So, every farmer knows that they should use fertilizer, they should use better seeds, they should use better technology, but they're very worried that if they do and then they get a bad year, they're going to get in debt. They're going to have, then maybe they get in debt and they need 3, 4, 5 years to just go back to normal financial situation. So they prefer to don't spend money, don't invest in technology, just to be sure that they don't get in big debt. But if you do that, what happens? What happens is that in most of the years where the conditions are close to normal or better, because we're using technologies that are not taking advantage of the potential production, then you lose a lot of money. And if you sum all these missed opportunities, of course, it's much bigger than what they lose in the bad or the very bad years. The problem, and it's understandable that farmers are risk averse, the problem is that only one year like this can make them out of business. So, if you want to invest in the right technologies, what we need is tools that cover these situations. That's what index insurance or weather index insurance or climate index insurance are. We use climate index insurance in that sense. We don't use it as a financial tool to cover damages. We use it as a financial tool to stimulate the use of the right technology. And then the last concept that I wanted to mention with you, discuss with you. We said climate change, the problem is the cause. We need to fight the causes. We need to reduce greenhouse gases emissions, mitigation. How do we reduce the net emissions of greenhouse gases? Two ways. We either reduce the emissions with better energy, so more renewable sources for energy, more efficient transportation, or you remove carbon from the atmosphere, which is normally known as a carbon sequestration. And this carbon sequestration and carbon footprint, what is a carbon footprint? Is the amount of CO2, of carbon that is being emitted to produce 1 kilo of coffee or 1 kilo of meat or 1 liter of milk. So you go to a supermarket in England and you buy a pint of milk, and they'll tell you what is the carbon footprint of that milk. You already start to see this in coffee too, where you see some brands are showing things like CO2 neutral. Now, why is this important? First of all, it's a global responsibility. Whatever we can do to reduce the amount of carbon in the atmosphere is good for the whole world. But in addition, this may become non-tariff barriers, right? If countries may say, I'm not going to import country from this, I'm not going to import coffee from this country because the carbon footprint of that production is too high. I don't want to contribute to climate change. And so, or the opposite, by having very low carbon footprints, we can access market niches that are willing to pay a little more. It's something like it's happening also with fair trade, with not employing child labor. So these are things that we need to think. In the case of climate change, is carbon footprint. And this means that we need to measure the carbon footprint in the coffee value chain and measure it very well. We have to measure how much carbon is being emitted by each kilo of coffee that is produced, or how much is being sequestered. And this requires good research. We need to support research. It cannot be something like a marketing. We need good research. So, to finish, I think I'm a little bit late. Recapping: global warming, climate change, is caused by the enhanced greenhouse gas emissions. Mitigation, reducing the net emissions of greenhouse gases, is the key. That's where we need to put a lot of the emphasis. And there are opportunities in coffee and agriculture production systems to sequester, to demonstrate that we are not only not increasing the problem, we are helping to reduce the problem. So opportunity for the coffee production is sequestering carbon. But even if we do everything right, the climate will continue to change, and we need to improve adaptation. It is very difficult to know what the future climate will look like in the future. We know that temperature will go up, but we don't know how much. We know that rainfall is very, very uncertain. So when you see these beautiful maps with reds and greens, don't trust them. Remember that behind that color there's a big uncertainty. So we don't know. The truth is that in science, we don't know what the future climate will look like at the scale that we need. But what we know is that it's very, very likely that the year-to-year variability will increase, which means more frequent and more intense extreme events like droughts and floods and heat waves. So, what is the best way to improve adaptation, to be prepared to climate change? Start by improving adaptation to current climate. What can we do today? Invest in breeding, technologies, information to reduce uncertainty, and finally, knowing that we will not be able to manage all the climate-related risks, think of effective financial tools to transfer the rest of the risk. For example, insurance. So that's all, and thank you guys very much, and I hope we have time for some questions. So back to you, Hannah.
Just a minute here to talk with all of you about some of what World Coffee Research is doing and how we're using this concept of interannual variability to guide to deepen our knowledge about variety and variety performance and how some of that feeds back into the breeding. And then we're going to jump into a Q&A session with Walter. So just very briefly, and I won't talk for too long, we had the opportunity at WCR to talk with Walter for about the past year. We've been talking with him. And one of the first conclusions that we came to after beginning to really think about climate change in the way that he's describing was that we needed to change the way that we talk about climate change as an organization with all of prior to even thinking about the impact on research. Understanding better the limitations of climate models and the way that uncertainty is sort of compounded on top of uncertainty when you're dealing with averages over both, significant periods of time and also significant periods of space. It led us to understand that we needed to move away from simplified statements that depend on long-range models. So some of you might be familiar with this image or this basic, fact about coffee, that suitable land will decline by half by 2050. That is based on the kind of model that Walter describes, and it is research that WCR supported and engaged in, looking at the suitable land area for coffee between now and 2050. 2050 is no longer as far away as it once was. But even so, understanding that these systems are so dynamic, one of the things we realized, and one of the values of having a fact like this at our disposal, is that it as Walter talked about with the IPCC and the origin of these models, it does help people. It galvanizes action, right? It creates a sense of urgency. Oh my gosh, suitable land will decline by half. But when it comes to actually designing interventions or thinking about how we address climate change, how we assist coffee farmers to adapt to climate change, it becomes much less useful. And as an organization, I think we began thinking about a year ago that that idea that we needed to galvanize attention and action around climate change, that moment had shifted and passed. That really, I think it's sort of it's not really up for debate anymore in our world. And I think that most of the organizations that we work with are very much on the same page. So that urgency around communicating the magnitude of the risk, I think we all get it. And it's really more about moving on to action and to thinking about these challenges. So that was the first thing that we did with this new way of thinking about climate change, was we changed how we talk about it and how we think about it. So you'll see that we no longer reference this this fact or these kind of talking points in the same way anymore. On the research side, which is where the fun, the substance really is, I just wanted to talk for a minute about one of our kind of most significant research programs, which is our International Multi-Location Variety Trial, and how this trial really captures that concept of interannual variability and is a tool that we have at our disposal now in coffee for thinking about adaptation along the lines of technology and better varieties for farmers. So some of you might be familiar with this program. It is the first trial network that we installed. We have 25 trial sites in 15 countries. They each have the same 30 varieties growing on them. And the trials were installed starting in 2016. Some of them were installed a little bit later. And we're just kind of getting to this exciting milestone this year where a number of those trials have now reached kind of commercial, their first commercial harvest, right? The trees need to grow for 3 to 4 years before you have a commercially viable harvest. So we're just really starting to be able to turn this network on in terms of getting good information out of it about how many of these existing varieties, but they're good varieties, and most of them have not been tried in all of the locations where they're currently being tested as part of this network. And what that means is that we are capturing, because of the breadth of the trial, the amount of space that it covers and all of the different environments that these varieties are now being placed in and exposed to, but also the timeline of the trial. So it's over multiple years. So when you add up the kind of the temporal and the spatial scope of the trial, you're capturing a lot of interannual variability. You're seeing how these varieties are performing in a lot of different environments and under a lot of different conditions. And that means that it's that includes any extreme kind of weather events that might happen over time, which is, as Walter was saying, these are the things that are really the edge events that push a farmer in or out of coffee, right? A super severe drought or a hurricane or something like that. So one of the kind of exciting examples that comes from this trial network about how this principle works. In 2017, one of our trial sites in Laos had a severe frost. The temperature dropped to just above freezing early in the morning. And as you can see from the photo on the left, almost all of the varieties were severely damaged. Most of them died completely. They were not able to survive that level of coldness. However, some of them did not. And you can see the picture on the right that there's a row here in the middle where there's still green leaves left where those plants have survived. And it turned out that the varieties that survived were mostly Brazilian cultivars, which have been selected over time for frost because frost is more prevalent in Brazil than it is in many other coffee producing areas. So it's something that breeders have actively worked on, but also F1 hybrids. And those F1 hybrids that were in the trial had never been tested outside of Central America. They were developed in Central America. They'd never been tested outside. And that was really critical because we understood in principle that F1 hybrids typically are resilient and have a lot of capacity to handle difficult situations. They can produce more, they can handle disease, they can tolerate disease generally a little bit better, but we had never seen them exposed to a severe frost like this. And so it really deepened our understanding of exactly what the kind of edge potential of these varieties is, which is really critical. So, you might say, well, frost is not the biggest problem, right? It's drought, or it's rising temperatures. But as Walter pointed out, one of the things that is happening with climate change is that extremes are increasing in frequency, and that does include in many coffee producing regions increasing frost. So this was a really important learning for us. So this is just another quick example to show you kind of how the fact that we have these many varieties across multiple locations. This is the first production harvest data. It just came back to us a couple of weeks ago. We are very, very excited about that. What this doesn't show is time scale. So you can see here that performance does indeed vary across locations, in some cases pretty significantly. Anywhere that you see a line crossing, that shows that the relative success of a variety is different in different places. And you can see that there are a lot of lines crossing, which tells us that some varieties are better optimized in some places than in others. And that is also very important information for us to have in terms of guiding recommendations for countries about what optimal varieties might be. What we're very excited to add to this analysis over the next 2, 3, 4 years is the temporal variability. So as these different locations are experiencing different weather conditions, we will also be able to see how those impact performance over time. And again, most of these varieties have never been tested in this wide amount of space or across time in this way. So it's really enriching our understanding of what's working, and ultimately the goal will be to look for varieties that have high resilience, that are able to perform in those edge conditions, and elevate them as recommendations for farmers. The other critical aspect of this is that you don't just want to test something on a research station site, because those are generally sort of optimal conditions. They're being cared for by technicians who have access to all the things that you might need to sort of optimize plant performance, like fertilizer and pruning and all of that. So you also want to test varieties in real world conditions. So on farms with farmers, with a range of different kinds of farmers, from more technified farmers to smallholders. So that is also part of what we have happening. And this is just an example from Latin America, but a subset of the varieties that we're testing on those research station sites are also being tested in farmers' fields in a number of countries. This just is a small example of some of the varieties in some of the countries, to understand what actually does work for farmers, because you can have something that looks really great on a research station site, but if a farmer doesn't like it for some reason, then the likelihood of them adopting it or adapting it is low. And between these two pieces of data, we should have solid recommendations for a number of countries from 2023 to 2025, depending on when the trials were initially installed. So that's very exciting to us. I wanted to offer that you're welcome to reach out to either of us with questions if we don't get to them now, and just to thank all of you for joining us, and to invite you to post your questions if you have any in the Q&A tab. I'm going to sort of sort through them and try to consolidate some of them and ask some to Walter. And I'm actually going to start with my own question. So Walter, as you know, I live in Portland, where we have been trapped in this incredible cloud of wildfire smoke since last Thursday. I have not actually seen the sun since last Thursday. So all of this sort of extreme weather variability feels very believable and real to me right now, personally. And we have family. I have family that with respiratory issues that has had to leave the state because of this, and are seriously considering sort of permanently moving. So I guess they're my first kind of personal climate migrant connections. If I translate my own experience to that of a coffee farmer, and I think about a really extreme year like the one we're going through here in Portland, whether it's like drought or monsoons or whatever, I can see that it's not about this sort of incremental, 0.1 or 0.01 degree rise in temperature that pushes a farmer out, or that you're trying to optimize your farm for that it's really about surviving extreme weather and being able to make it through to the other side. I'm curious for your reflection on what you think this dynamic might do to coffee production in particular, or agriculture in general. How will it affect the number of farmers globally over the next 10 years? How do you think it plays out at a sort of macro scale for agriculture?
So I think that I believe that farmers have known that it's more important for farmers to have a more or less stable income, a more or less stable production, than to have this, for example, magical technologies that sometimes can give them huge income. Farmers, I mean, that's what they do. Farming is probably one of the highest risk occupations in the world. And so I think farmers have known this. What I think is that how the scientific, the technological community can help in that is, first of all, quantifying these things. Farmers know that a volatile income is bad for anybody, because you think you're doing fine, and then you get a late frost or an early frost, and then you're completely destroyed. So the one thing that I believe we, as the centers that generate knowledge, is quit thinking about, or give less importance to the mean expected result, and look more at what is the risk of having losses, and what is the tolerance that a farmer or any farming system, what is the level of a loss that a farmer can tolerate, instead of just being obsessed with what is the mean income in the last 10 years, because one bad year erases the whole thing. And then the other part is understanding what are the parts of those risks that we can help to manage. What are things that we can help to make farming more resilient? And also understand what are the things that we cannot manage, and therefore design insurance tools for those portions of risk that we cannot manage. And be sure that those insurance tools, those financial tools, are accessible. The reality in agriculture in the world is that in most countries of the world where they have traditional insurance, it's just subsidies. It's like hidden subsidies, right? Now, we are working in places like Ethiopia, Vietnam, Bangladesh, Senegal, Guatemala, in places where countries cannot subsidize farmers. And so, and we are still designing, we and other groups, we're still designing financial tools that are accessible. These index insurance tools are very good, and they're accessible for small farmers, for vulnerable farmers. So, in summary, I would say, one, move our attention from the mean and look more at the probability of having losses and understanding the tolerance for the losses. Two, understand what we can do to improve the management of the risks associated with that climate variability. And three, understand what tools can be developed to transfer the risks that we cannot manage with technology.
I'm interested, and there's a few different questions that are kind of coming in along these lines. I'm going to try to consolidate them into a single question about the different roles for different kinds of actors in all of this. So, clearly there's a role for governments and policy in, even thinking about the kind of data or the quality of data they're looking at to guide decision making and the kinds of infrastructure that they build and plan for the coming years. Tools like index insurance, weather insurance, how to implement those and make them accessible to farmers. There's business, right? What can a business like a coffee roaster do? What are their responsibilities and opportunities in all of this? And then in coffee, we also think, of course, a lot about consumers. what is the role for coffee drinkers in all of this? Do you have thoughts about those different kind of levels of actors and what their different both responsibilities and opportunities are, and how those align or don't align?
So two things. One is that I'm very happy that our institution finally started working more actively in coffee, because coffee is a crop to me that has not received enough attention, in the sense that, if you have 1 hectare in Ethiopia, you're not going to make a decent life living by growing wheat. It's impossible. The way out of poverty, if you have a family of 3 kids and you have 1 hectare of land, is not growing wheat. Now, if you can start growing high value crops, that's a good, if you want to improve nutrition of poor people, the most effective way to improve nutrition of poor people is to increase income. It's not to plant a diversified diet in a small farm. It's to increase income so they can buy the right food. So first of all, very happy that finally we're working in coffee. Now, in the insurance part of coffee, one of the things that we learned in the last 20 years in every crop that we work is that the products have to be co-designed. So you have to sit down with everybody in the value chain that has a role to play and say, understand, for the different actors in the value chain, how important is for you to get a supply that is constant, the quality is reasonable, is predictable? How important is that for you compared to getting, very variable supply?
Yeah.
How important is for the farmers? How important is for the different actors in the value chain? But then involve them and say, how much are you willing to pay? There is even games. It's very, very interesting. There are some games in which you sit down with farmers and say, how much are you willing to pay if this happens, if you do this, if you want to cover this? And so but then you also involve the other actors of the value chain. And of course, then you have to have the people, the reinsurance and the insurance companies in the countries. And so the message is, everybody has a role in the value chain. Everybody has a role in these activities, and it's very important when we start designing these tools that they are involved from the beginning. They're involved. They know what's going on. They know what is the advantage for each one of the members in the value chain, how much it's going to cost, what are they going to cover and what they're not going to cover, what are the possible errors, so that then you design the tool, everybody knows what's happening.
Yeah. Somebody asked a good question here about, hold on, let's see if I can find it. It went away. Okay, I'll wing it. Was basically, besides weather insurance, are there other ways that actors in the value chain, especially the near part of the value chain, that importers, exporters, roasters, can involve themselves in risk reduction? Like, what are the mechanisms that exist for helping farmers reduce the amount of exposure that they have to climate risk, besides insurance?
Yeah, so I don't know enough about the coffee value chain to answer that question in a responsible way, because I know that there's a lot of subtleties in the different value chains, especially in different countries. But I think the concept that works for coffee, for cattle, for corn, the concept is, if you sit down with the main actors of the value chain and you define what are objectives. For example, and this, there's some companies that place a lot of importance in the environmental impacts, footprints of what they sell, because their brand is, I am environmentally friendly. There are other companies that place more importance in the stability of the income of whatever the priorities of the different actors in the food systems, especially the importers or and then once you understand that, then I think it's very easy or relatively easy to demonstrate that a little bit of investment in the right place make a big difference.
Yeah.
A little bit of investment in the right financial tool makes a big difference. But also a little bit of investment helping, a research center to develop the right variety or to develop the right technology to reduce this variability of yields. That makes a big difference. And we have a lot of WCR is an example, but we have a lot of institutions around the world that this is, the reason why you guys exist is because of the value chain understands that there's a lot of technology, a lot of knowledge that you can generate and help to, reduce this volatility of income. And so, again, I think that the key is to understand that it's so different. The value chain in different countries is so different, but it's to understand what is the priorities and how, and be very pragmatic. Is demonstrate that a little bit of investment in this area will end helping you a lot. Help you a lot because your brand is going to be continue being environmentally friendly, or because you're going to get a very stable income, or because the quality of the beans you're getting is. So involve them, involve the and show the cost benefit.
I can speak just very briefly to some of how this plays out in coffee or exists in coffee already, and it is often the either exporters or co-ops, like sort of those groups that are working very closely with producers on the ground that are helping make access to these kinds of risk management tools. So, for example, there are exporters and even importers like Sustainable Harvest that have people who help farmers access price risk management tools, which is different than weather risk management tools. But it's something, it's very difficult for an individual farmer, and especially a smallholder farmer, to access those kinds of tools on their own. It requires some financial literacy. And so it is often these groups that are, it's in their business interest too, right, to be supporting farmers to be successful. So,
Right.
One opportunity if you're a roaster or, sort of sitting a little bit toward the other end of the value chain is to talk with those organizations that you have relationships with that are closer to farmers to understand better what kinds of tools they're thinking about, what kinds of tools they have available, and begin asking questions about what they might be able to produce. In terms of other risk management tools, our space at WCR is really varieties and technologies, and a really simple thing that we work on that people don't think of as a risk management tool, but it is nurseries. If you're going to put a tree in the ground and that tree is going to be producing for you for 30 years because it's a tree crop, and you're putting an unhealthy tree in the ground versus the healthy one, the lower potential performance of that unhealthy tree over the life of 40 years exposes you to a lot more risk than is necessary. And so cleaning up nurseries and helping enable them to produce better quality plants is a risk management tool. So there's really a lot that happens already that is about reducing risk. We just don't necessarily think of it in those terms. I want to recognize that we're at time, we're at the hour. We have a lot more questions that have come in, so I will commit to looking at all of these questions, forwarding them to Dr. Baethgen, or answering some of them ourselves. There's some additional questions about diseases and pest prevalence and all of that. Actually, quite a few questions about that. So we will put together some answers for you and send them on. I just again want to thank you, Dr. Baethgen, for taking the time to talk with us about this. We're so lucky to have your insights and knowledge brought to bear, and I know this was really a wonderful experience for the people that joined us today. So thank you again, and we look forward to more.
No, it was a pleasure, Hannah. And as I said, our institution is working, almost entirely with developing countries, and I'm really excited about working with coffee because, as I said, I think this is one of the most realistic way for me to see a very good option to take farmers out of poverty. And so for us, the high value crops in our work have become more and more important. So it's great to be in touch with you guys, and I'm happy to help with everything we can.
That's awesome. That's awesome. Well, take care of yourself, and
Thank you.
we'll see all of you hopefully at our next webinar. Thank you so much for joining us.
Bye, guys.
Bye.